Hi, in this video I will be showing you problem number 4 of section 11.9 of your homework from WebAssign. Find a power series representation for the function f of x equal to x squared times tan inverse of x cube and determine its radius of convergence. We'll start off with the expansion for tan inverse of x cube and then multiply that with x squared. So in order to get tan inverse of x cube expansion, we'll go from tan inverse of x, which we derived in class. So tan inverse of x can be written as integral of 1 over 1 plus x squared dx, which is integral of 1 minus x squared plus x to the power 4 minus x to the power 6 and so on. So if you integrate each term, you get x minus x cube over 3 plus x to the power 5 over 5 minus x to the power 7 over 7 and so on. This will give a constant of integration which will be equal to c. Now we have to determine this constant. So for that we are going to plug in x equal to 0. So tan inverse of 0 would be 0. On the right hand side all the terms have x in them. So which will be 0 plus c except c. So c value equal to 0. So this gets plugged in back here. So tan inverse of x would become x minus x cube over 3 to then x to the power 5 over 5. The terms are alternatively positive and negative. And I notice that all the exponents are odd. So this can be written as negative 1 to the power n, x to the power 2n plus 1 over 2n plus 1. Any odd number can be written as 2n plus 1. So the expansion of tan inverse of x is this expression over here. Now we'll change this x to x cube because in our problem we have tan inverse of x cube. So we're going to write tan inverse of, change the x to x cube. So in the power series representation it becomes n varying from 0 through infinity negative 1 to the power n. X gets replaced by x cube. It's x cube to the power 2n plus 1 over 2n plus 1. If we expand that further, we get sigma n varying from 0 through infinity, negative 1 to the power n, x to the power 3 times 2n, which is 6n, 3 times 1, which is 3, all divided by 2n plus 1. Again in our problem we have f of x equal to x squared times tan inverse of x cube. So if you write x squared times tan inverse of x cube, all you have to do is to multiply this power series representation that we have for tan inverse of x cube by x squared. Multiply that by x squared. So the expression on the right hand side becomes x squared times sigma n varying from 0 through infinity, negative 1 to the power n, x to the power 6n plus 3 divided by 2n plus 1. So if we move the x square inside, we get sigma negative 1 to the power n, x to the power 6n plus 3. The outside exponent 2 becomes positive exponent 2 inside divided by 2n plus 1. So this would be sigma n varying from 0 through infinity, negative 1 to the power n, x to the power 6n plus 5 divided by 2n plus 1. So anytime you write the power series representation, we have to also give the radius of convergence. So you notice that this whole series came from the power series representation of tan inverse of x cube, and then that the radius of convergence for that one would be 1 because it came from the geometric series. So absolute of x cube would be less than 1, or absolute of x would be less than 1, which means the radius of convergence for this thing would be equal to 1. So the radius of convergence of this power series is equal to 1, and this is the power series representation of x squared times tan inverse of x cube. Hope this video helps.